Here we have a multiplication problem of two different nth roots, but the indices, plural of index, those match. And when those match, that means we can just kind of scrunch the two things together and multiply these two guys like we normally would using our normal properties. I would take these coefficients and multiply those together. That makes 120. And then, of course, x to the fifth times x to the fourth. Since we're being asked to multiply, but we're dealing with the exponents, we'll add those exponents to get x to the ninth power. And from this, we're going to take the same steps we took in the previous examples where we'll simplify this. We're keeping in mind that this index tells us or indicates to us that we're trying to find what multiplies by itself 3 times to give us 120 and x to the ninth, and that there's not an exact thing that multiplies by itself 3 times to land on the 120 or the x to the ninth. There'll be some stuff remaining inside of the radical. If I take that 120 and I break it up into a prime factorization, I get something that looks like this. Doesn't really matter how you break up that 120. If you do all your math correctly, you will end up with 3 2s, a 3, and a 5. So I will rewrite the problem that I ended up with here as the third root of 2 to the third times 3 times 5 times x to the ninth. Because I have an index of 3, I'm thinking about the fact that I have to multiply something by itself 3 times to make this. And I'm going to consider each factor separately and try and break them up or divide them evenly among the 3 slots, taking them one at a time. So if I have 3 2s to work with, then everybody would get a 2, and there would not be any left over at all. So there will be a 2 on the outside of my radical. I'm going to write that down here. When it comes to the 3 and the 5, there's only one of these and there's only one of these. So I can't put them in any slots at all. So they're both going to remain inside of my radical symbol, 3 times 5. And x to the ninth, if I had 9 x's to split among 3 slots, every single one of these could get 3 x's. 9 divided by 3 is 3, and there's nothing left over. Nothing remains, which means there's nothing left on the inside of the x's. It's just x cubed on the outside. So my final answer, of course I'm going to simplify this because I can. The best final answer is 2x cubed times the cube root of 15. So stay focused, one thing at a time. Good luck.